Alright, what's up, my skibbity sigmas? So first we will be talking about significant digits. Alright, so for example, if I have this is like 0 or something, and this is like 10. Oh, this is like not specific or anything, nah. And like the thing, and let's say my like dick is like this long. Oh, you bet. That's like 10 times larger. But anyway, let's see. This is like, we have to estimate, like, nah, like, boom. Like, that's like close enough. Like, that's like 3. So since this is like not specific whatsoever, since I just created those lines, we just use one significant figure because this ruler is not specific. Oh no. So if you have a ruler that's like with actual lines like this, 0 through 10, you get 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. Oh, that's more specific. So if you take this, oh, I was wrong. So this is like 4. But since there's like more lines, it's more specific. You have more significant figures. So this is 2 significant figures. 2 sig figs. So 4 point, let's say that's like, we're guessing this number 2. So if you have a ruler like this, that's like very specific. So like our reference thing is like about here. So now we can use 3 sig figs, and this is like, I'll just make it normal. 4, 5. Yeah, whatever. So basically, if there's like more specific information given, then that means there's more sig figs. So this would be 3 sig figs now. So let's say that's like 4 point, like, I don't know, 1, 5. Yeah. So that's just significant figures. Now, accuracy versus precision. Let's say you have a dynamite right here, and you are an Edgar player right here. So the target is like this. If you are not accurate and not precise, you would do a Ryu, and then boom! Oh, that's like not even close. And then if you're a dynamite, and then we're not if you are accurate but not precise, you will be closer to the dynamite. All right. However, if you are precise, you will constantly be jumping right here, or here, boom. It's all in one area. Therefore, it's precise and not accurate because it is not close to the dynamite. Oh, nah. And the opposite, like boom, boom, like right there. Boom, boom, boom. Oh, that's like accurate and precise. Oh, nah. Alright, so your base units is grams, meters, and liters. So grams is the mass, meters is the length, and liters is the volume. Also, you should know your prefixes, hopefully. If you don't, I will write them. Alright, excuse me. Alright, so deca and deci are 10 away, multiple of 10 away. So decimal is 0.0, 0.1, because you are moving the point to the left, and opposite for deca, obviously, because these prefixes are 10, so this would become 10 times and 0.1 times. Centi and hecto, think of like a centipede has like 100 legs. I think, I don't even know. Hecto, I don't even know. Just think of opposite of centi. I bet. This is like 100 times, and this is 0.01 times. And then for milli, like my dick, that's like 1,000 times less. Boom, and this is like kilo, like my dick. All right. All right. Onto like dimensional analysis. So for example, if you're given like 5 inches and you are trying to find feet, so you're trying to divide feet by the amount of inches in a so you're trying to divide the feet by the amount of inches in a feet. So you're trying to get feet by dividing 12 inches because there's 12 inches in 1 foot. And then you're just multiplying. These two have to cancel out. The inches can't be at the top because that would equal into inches squared, and you don't want inches squared over feet. So you want just feet. So then you would just do 5 divided by 12 equals the amount of feet. So yeah, for let's do nicer numbers. How about 24 inches and 12 inches? 1 foot, boom. 24 divided by 12 because you're multiplying the numerator by the numerator and the denominator by the denominator. So 24 over 12 equals 2. Yay, I bet. Let's see. Alright, let's move on to matter. So matter is anything that has mass and takes up space. So an example would be this pencil, this cup of Arian's calm, this paper, and obviously there are 3 states of matter, like in Pokemon. So there's solid, like Dialga, liquid, like Palkia, and gas for Giratina. So what is not matter? Light, sound, energy, and like heat. Oh my god, what is that? Oh nah. Alright. So a characteristic property, is a property of a substance that is unique to that substance. I don't know. So, for example, there would be color, density, boiling point, melting point, freezing point, all that. So, obviously, a physical change is the form or state that is changed, but the type of matter remains the same. So like if I get this paper from earlier and crumple it, boom, that's a physical change. The matter did not change. So yeah. A physical change can also be reverted back to its original form. So, me crumpling this paper and back to its original shape is a physical change because it can be reversed. So, next up is chemical. So chemical changes are like you're combining 2 or more or like rearranging them to create a new substance, such as like burning paper or creating a cake. So this is your paper, this is your fire. What the fuck? Alright. this is your fire. So if you put the fire, like, oh no, your paper is like burning and like shit. Oh. So yeah, that's a chemical change because you cannot revert this back into that. Also, a chemical change usually produces light, heat, gas, odor, sound, or a color. Physical properties. Can be seen or observed without changing the identity of the substance. For example, oh nah, I just realized how much I missed that. So physical properties, so it could be color, size, and density. D. So yeah. So chemical properties is the ability of a substance to undergo a specific chemical change, such as acid, flammability, and toxicity. Okay, so next is atoms, particles, and molecules. So let's see if I create this. Boom. Boom, boom. Let's see. Boom, 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 boom. All right, so each one of these individual things is an atom. So boom, boom. However, this whole shape right here is known as a molecule. And they're combining through a chemical bond. And particles are like the total of all the things. So like 1, 2, 3, 4, 5. These aren't counted as 2 because they are bonded together. All right, so going back to mass, volume, and density from earlier. Mass is the matter, volume is the space, and density is the mass over volume. So you need to know that the equation is equal mass over volume. Yeah. I like to think of it as DMV, like drivers something. So I think that's what it stands for. I don't even know. I can't even drive yet. Oh no. So for mass, the mass is unit. The units are, for mass, grams. Volume is milliliters or centimeters squared. Density is G, grams over milliliters, or G over cm cubed. So you should remember that that 1 milliliter is equal to 1 centimeters cubed. All right, so the density of water is 1 gram per milliliter. So this is your water, 1 milliliter. If an object is less than 1 gram over milliliter, then it will float. Boom, that's your object. However, if your object is over 1 gml, it will sink, obviously. All right, so density and temperature. So as the temp increases, the density decreases, and the same vice versa. When it increases, this decreases. I bet. Okay, then we should do a practice problem. So what is the density of a 5.4 gram golf ball if the volume is 20.4 milliliters? So in order to do this, you would do 5.4 grams, because remember, your equation is mass over volume, and your mass is 5.4 grams, your volume is 20.4, you should get 0.26 G per ml. I bet. However, if you're given like kilograms, for example, so 0.56 kilograms, you would have to convert this into grams. How do you do this? You move the decimal three places in order to get to regular old grams. 560. Because remember, kilo is 1,000. So 560 grams. And you're given the density equals 19.3. So how do you do this? 19.3 is G over ml is equal to 560 grams over volume, because you're trying to find volume. So now you're just gonna multiply V both sides. 19.3 V equals 560. So you get 29.0155 ml, because 560 divided by 19.3 is 29.0155. Alright, that's unit 1. Hi, bet.